Assalamu alaikum. Good day, everyone. This is Dr. Salih Al-Rashid, and here we are together in lecture 11, AI Application Development Lifecycle. How to develop an AI application. So today we are moving beyond the magic of artificial intelligence to look at the machinery, not the code, but the process of bringing an AI project to life. We often hear about AI breakthroughs, success, but the reality is that many AI projects unfortunately fail. Why? It is really because the development life cycle, the break of development life cycle. So in this, inshallah, lecture, we'll be talking about four, points. Hopefully, inshallah, by the end of this lecture, you will be able to explain why AI projects commonly fail. And then you should should understand the difference between business success matrix and machine learning performance matrix. And this is one of the biggest reasons of failing an AI project. Hopefully, inshallah, you will be able to describe the AI development lifecycle loop, and then we'll talk about an example of the development of AI lifecycle. So, where do AI projects fail? There is a number of reasons. We will be talking about 6 of them that lead to AI projects to fail. The first one is, an undefined problem. So the problem is not clear. The outcome of the problem is not clear. The outcome, what we call, the success matrix, is different between different people. So the business will look at the success matrix in a certain way. The business goal of developing AI, application, and the technician success matrix, how the technician, or what we call machine learning, look at the success. So we'll talk in details about this part. The second is poor data. The data is not, maybe not sufficient. The quality is not sufficient, or does not fail within the domain of the application that we are talking about. Another reason is when you develop an AI application, you need to use a certain model. We will be talking about this in details. So if you choose the wrong model, then it could lead to to the project to fail. Another reason is insufficient testing. So you don't test it enough, which lead to maybe the performance issues within the application. Another reason is poor integration. So the AI system needs to be integrated with existing systems. So either to take data from or to give data. This is another issue that need to be addressed. And finally is the lack of ongoing monitoring. Uh, the, AI project is not just do it and that's it. No, it needs monitoring, continuous monitoring. So if you stop monitor the system, then it will lead to a high probability of failing. So you need all the time to take care of these uh, issues. One of the biggest issues, what we call is the heart of most important failure points, is the defining the success, how business define it, and how machine learning define it. When you build an AI, you have two completely different groups of people thinking about success. The first is the business, and they care about things like, does this save us some money? So the value. Does it make our customer happier? So user satisfaction. Does it reduce error in our, for example, warehouse? So the business impact. These are the real world, human-centric goals, and this is the business what they care about. On the other hand, the machine learning side, they care about technical metrics like accuracy. Is our model 98% accurate? Can it process, for example, 1,000 requests per second? So we look at these points. The disaster happens when these two sides do not talk to each other. You can have an machine learning engineer creates a model that is 99.9 accurate. It is a technical masterpiece, but if that model solves the wrong business problem, or if its level of accuracy is not actually needed, I don't need that accuracy, the project is a fail. You have built a perfect solution to a problem nobody has. So the first step of any AI project is not writing the code. It's asking what business problem we are actually trying to solve. We need to understand the business part first. In the context of AI application development, success is measured through two distinct lenses, business matrix and machine learning matrix. So understanding the differences is crucial, because high performance is in one does not guarantee success. So let's talk about the business success matrix. These metrics focus on the real world values and the utility that AI system provides to the organization or its user. They answer the question, is this product actually helping our business? So user satisfaction measures how happy the end user are with our AI tool. The business impact or value generated, the tangle return on investment, such as cost reduction or increased revenue. Also, adoption rate, how widely the solution is actually used within intended environment. These are the success matrix that the business look at. So what about the machine learning performance matrix? What the technician look at? There are technical mathematical measurement used to evaluate the model, the AI model. So how accuracy during the development testing phase. So accuracy is the percentage of total prediction that were correct. So for example, 95%. Precision, the ability of the model to identify only relevant instance. F1 score is the balance between precision and recall, often used when data classes are imbalanced. So there is imbalance between the data. AUC, area under the curve, performance, it's a performance measurement for classification problem at various threshold settings. So when we reduce the gap between business and machine learning, it will increase the success of our system. So let's have an example. A model accuracy improve from 92% to 97%. Okay. So what they in here, they believe that it's success because we have increased the accuracy by from 92 to 97. Okay. However, the system become significantly slow. So the system become very slow, leading to increase of customer complaints. So the user satisfaction is low. Even if I put the accuracy is high, but the user satisfaction is low. So here it is machine learning success, but in the business side, it is a fail. So this demonstrates that while the machine learning matrix improved, the business goals were failure because the technical improvement negatively impact the user experience. So the success of AI development require ensuring that technical performance directly translates into business values. Okay, the second part, we will be talking about the AI lifecycle loop. This brings us to the central idea of our today's lecture. The AI life is not a straight line, okay? It is a loop. As you can see, it starts from the problem and goes on and on. Because AI is never truly finished. AI is never truly finished. It needs constant care and attention. We are going to break this loop down into 5 major stages. So the problem, the data, and then the model, and how to deploy it, and then how to monitor it. So let's start with discovering the problem discovery and the scope. This is the ask the right question phase. So before starting of anything, before of single line of code is written, before any data collected, you need to be a detective. Who is the user? Someone needs to answer that question. Who is the user? Is it a customer? Is it a warehouse employee, for example? Is it a doctor? So we need to know the level of customer. What is decision will the AI assist? Will it recommend a product or flag potential disease, for example, or drive a car? So I need to know what are the decisions that is needed. And then when do or how often will it be used? Is it every second? So I need to make sure, the performance. Or is it once a day? So if you can't answer these questions clearly, you are not ready to build an AI. You are ready to go back to the drawing board and find answers for these questions. The second one is data collection and preparation. This is often the longest and most unglamorous part of the whole process. People love to talk about the fancy AI model, but the truth is if the garbage in, then the garbage out. So you need to figure out how to collect the data, the collection strategy. Where does the data come from? Is it legal? Is it legal? So you have the permission. Is it ethical to use it? Are you allowed? Is it ethical to be used, these data? And then the raw data assessment. When you collect the data, you need to assess your data. Okay, is your data any good? Is it good data? Is it fully correct? There is no error. Is there any missing important pieces on these data? Is it bias against a certain group of people? So you need to be fair. And then you start cleaning. If you find some issues within the quality or the completeness of your data, then start cleaning and preparing, pre-processing your data. This is the tedious work of fixing error. It's long process. Removing duplicates, for example, and standardizing formats. Make the format is standardized. Think of it as washing and chopping your vegetables before you cook. So you need to clean it and cut it to a certain format so you can use it. Feature engineering. This is the deciding which piece of information are actually important for AI to learn from. Not all the data is needed. And finally, you must document everything. Where the data came from, you need to document everything. Where the data came from, who labeled it, what bias might be in it. Is it just good practice? So you need to document everything. After getting this done, you will move to the other point, the third stage, modeling and prototyping. This is what most people think AI is all about. This is where you choose your algorithm, the model. This is where you choose it. And in our course, we will not go deep into the different models and how you choose it, because it's too technical. But notice the second bullet point. Before using the AI in the real world, you test a prototype. This is crucial. You don't build the whole house at once. You build a small model a prototype and test it in a very controlled environment, very certain data, does it even work? Does it do what we hoped it will do? This is where you fail fast and cheap. So you don't fail slow and expensive. If there is any problem, then okay, you're still in a controlled environment, still a small part, there is no harm on it. So if you fail, you will fail cheap. The fourth stage is deploying and integration. This is the go live moment. The AI leaves the safety of the lab and start facing the real messy, unpredictable data from the real world. And this is where many brilliant AI projects die. Why? Because integration is hard. Integration part is hard. The AI might be great, but if it's slow, then if it crashes, or if it forces people to completely change how they do their jobs, they will hate it and refuse to use it. A successful AI support people. It should fit into their workflow like helpful assistants, not like disruptive new boss. This stage is all about software engineering, user experience, and change management, not just, AI. The stage 5 is monitoring and maintenance. So now we reach the final, yet arguably most crucial stage of the loop: monitoring and maintenance. There is a common misconception in AI development that once the code is deployed and the system is live, the job is done. In reality, the day you launch is the day the real work of managing that AI begins. Unlike traditional softwares, AI is dynamic. It interacts with changed world, which means its performance can and often will degrade over time. So the performance might degrade. So let me give you an example. Imagine an AI that predict housing price. Okay, then a pandemic hits. Something within the country. So suddenly everyone wants to move to maybe another city or another country or to the suburb. Then the old data that AI was trained is no longer relevant. And this is what we call drift. Okay, this is what you call drift. Drift generally manifests in two primary ways. Data drift. This happens when the input data that AI receives changes. So the data has changed. So for example, a facial recognition system, a system that recognizes faces, is trained on people without masks, but suddenly fails during a pandemic because the input, the data has drifted. Okay, now the faces are with masks, and this does not match the training data. So this is a problem. Another drift is the conceptual drift, and this is more indirect. The input data might look the same, but the meaning of the target has changed. The meaning. So, for example, in a housing price prediction model, maybe a three-bedroom house is still a three-bedroom house, the same naming. But due to inflation, for example, or the change on the area or the neighborhood, its market value, the concept, has shifted entirely from what the model learned maybe 2 years ago. So, why does the drift happens? The drift happens maybe because of changing trends. So customer behaviors, fashion, different fashion, or language evolves. So they use different wording than the AI have learned. Maybe environmental shift. There is a new laws. There is economy inflation, or a global event, for example, a pandemic or war, which then change how the system function. The third reason why does the drift happens is the technical changes. A sensor on a highway gate might age and start predicting noiser images. The images quality is low. Or the software update in a different department might change data format, which is, the input now has different format. So you must constantly monitor your AI. Is it performance dropping? Is it making new kind of mistakes? And you must be ready to retain it with the new data or even redesign it. The life cycle loops back to the beginning of again and again. So it's always going back to the first. So after monitoring, it will go to understanding the problem, redesigning your system, and then the data, and so on, for the life of the AI development. So now let's take a case study. Okay, let's see all of these stages in a real example. Okay. We'll talk about JISR application, which is automated gate access system. Think of the system that control the gates at King Fahad, bridge toll. Instead of a person checking, the car, the price, ticketing, JISR app uses AI to automatically recognize the license plates and open the gate. This is perfect, simple example to work throughout the system life cycle. So, what is the problem? This is the first stage, right? Problem discovery and scope. We need to automate gate access. Why? To, for example, reduce delays for drivers, to improve accuracy, no human reading error, and to remove the need for manual scanning, which save money, save time, and so on. The second stage is data collection. The team realize the AI needs to be robust, so they don't just collect 100 easy, perfect picture of license on a very clear day. They collect thousands of images under different lighting, different weather condition, rain, sandstorm, at night, at dirty or slightly damaged plates. This is smart preparation. So you need to collect the correct data. So then there come the modeling and prototyping. The team chooses a model for image recognition. They train a prototype on their collected data. Then they evaluate it. Does it work on the sunny day photos? Great. Does it work in rainy night photos? Not so great. So they go back and find the night time data and then retrain the model. This prototype loops is very essential. After that, we will deploy and monitor and do the maintenance. The AI is installed at the first real gates. Read real cars, read the license plates with the real weather. Maybe we did not consider the high temperature or high humidity. So now by deploying, we will monitor. The team watches it like a hawk. Does it get slower in rush hours? Do a certain type of car plates, maybe from other country. Will it understand it? They are constantly checking for performance if it drops and do whatever maintenance needed. So the conclusion is that we have the AI lifecycle. We start from understanding the problem, going to the data, choosing the model, deploying and monitor it and maintain it if it's needed. So, building a successful AI is not magic. It's a disciplined, human-centered process. A process that starts with a clear problem, relies on a good data, require a carefully integrated and never ends. For a non-technical future leader, manager, or simply informative citizen, you do not need to write AI code. But understanding that life cycle is very important. Thank you for listening and see you in the other lecture, inshallah.